Can you solve this Maths Olympiad problem we have on the board? If you think you can, pause the video and make a guess. We are told to solve this exponential equation that 6 to the power of x plus 1 is equal to 3 to the power of x plus 2. We are expected to provide the solution for the value of x. The question says that 6 power x plus 1 is equals to 3 power x plus 2. Okay? Understand one thing. The base here is 6 and the base here is 3. And 6 and 3 cannot be expressed in common base. So all we have to do so that we can solve this is simply to take the logarithm of both sides. Because when we take the logarithm of both sides, it allows us to multiply the power to the log. Because this implies that because when we have logarithm of m to the power of n, we can simply write it as using the power n to multiply the log. So if we apply it here, what are we having? You can see we have log of 6 x to the power plus 1 is equal to, we also have to apply it here. So we have log of 3 of x plus 2. Okay, if we actually apply this law of logarithm, what do we have? We'll be having as x plus 1 in bracket. Then we have log 6 because we actually multiply the power x plus 1 to the log. And this is equal to, we'll still have to do the same here. So we have the power is x plus 2 here. So we have x plus 2. We just have to multiply the log. We have it as log 3. Okay? In our usual way of dealing with algebra, we are going to use log 6 to multiply these two terms in the bracket, just to open the bracket. So we have it as x log 6 plus, because log 6 times x is x log 6, then log 6 will times 1. That will give you just log 6. And this is equal to log 3 will times x. We have it as x log 3. Good. Then log 3 will times 2. We have it as plus 2 log 3. So since we have opened this bracket, we understand one thing, that we have this x here in this side of the equation, and we also have this x here in the other side of the equation. So we simply have to collect like terms. To collect like terms, we have to minus x log 3 here and also minus log 6, so that the one that doesn't have the variable x will be on the same side. So if we do that, what do we have? We have it at x log 6 minus, we are taking this one close, we have it as x log 3 is equal to, what do we have left? 2 log 3. 2 log 3. We can still use the same laws of logarithm here, that whenever we have a number multiplying a log, it can still serve as the power of the log, of the number in the log. So we can now write it to be log 3 squared plus, minus, we'll take away log 6, log 6. So what can you observe here? You observe that x is common in this too, so we factor it out. So if you factor out x, we'll be having x into log 6. If you factor out x here, we'll be left with log 3 minus log 3 is equals to, when you have 3 squared, it's simply 3 times 3. So we can write it as log 9 minus log 6. Okay? At this stage, what do we see? From another law of logarithm, which says that whenever we are subtracting logarithm of the same base, like log m minus log n, that we can take it as what? Since at a common base, log m, we just have to divide the numbers. So let's apply it here. If we apply it here, what are we having? X into log 6 over 3 is equal to log 9 over 6. Have it that x is here. 6 divided by 3 is 2. X log 2 is equal to, when we divide 9 by this, we are having it to be what? We can still have it to be log 3 over 2. Okay? Then the next thing we do is to divide through by log 2. If you divide by log 2 so that x can stand on its own, you also have to divide here by log 2. So that log 2 will cancel out everything. You are having that x is now equal to. So you can now also use this law again and make this to be the same. So you can now have it as what? Log 3 minus log 2, then divided by log 2. Okay? Fraction. So x will now be equal to log 3 over log 2. Are you getting it now? Minus log 2 over log 2. Okay? So what do you understand here? You can now see that x log 2 will cancel out log 2, getting 1. So this is now that x is equal to log 3 over log 2 minus 1. Okay? So the next thing we have to do is just to use change of base to solve this very well. To use change of base, you can now see that x is equal to, they have a common base of 10, so we can use log 2 of 3, then minus 1. Final answer to this is that x will be equal to log 3 base 2 minus 1. And that's the value for x.